Hello, my name is Paul Edwards. I'm with Danmark Company. I am your technical service advisor today on the DM Calcium Hypochlorite System. We're going to be talking about a lot of information today, and we're going to break it down in several different parts. So please bear with us today with the amount of information that we're going to give today, as well as other pieces of information through other videos. You'll have a combined, accumulated definition of what the DM Calcium Hypochlorite System is all about. So we want to thank you for your interest. If you have any questions, please contact Danmark at 817-822-5767. That's our technical number. You'd be talking to me, Paul Edwards, and I can go into some of the details that might have been left off on this video. This is a continuing education effort, so our whole goal here is just to get some general information across. We are not warranting this video, and we're not implying a warranty. This is a continuing education tool, and we're giving you information based on our observations. But at any time, if you need additional technical or warranty, you need to contact the manufacturer of the different components. If you have a warranty issue regarding pipe, then I would be able to address that for you. If you have a warranty issue regarding the pump system, we utilize the Dosematic pump system, so their manufacturer's warranty would apply there. And as far as performance of this equipment, there is no warranty or guarantee of any kind, or implied or in writing, that the system you're going to see is going to be covered by any warranty. So please get back with me on any specific questions you might have on that. Of course, you know, we have a normal parts warranty, which if you have a failed part, then we're going to take care of it. But as far as a performance or an outcome warranty, there's none of any kind. And I will be talking about general dynamics of the system, but you may have technical expertise at the plant on engineers and so forth, and they may be able to address things for you more precisely from an engineer standpoint. So please get with your engineering team and your quality control people and your food safety experts, as well as your regulatory officials, to get any kind of additional information that you would need. Well, we will begin in just a moment. Of the many advantages that the DM Calcium Hypochlorite System offers is easy to add the chemistry feature, okay? For example, if you look at this system, you'll notice that there's a cap that's on the top of this device here. This is where the calcium hypochlorite, our trade name is called Flaco Calcium Hypochlorite. Our Flaco product is added there on that level there. We actually have a strainer or a funnel in which you can put the funnel on the top of this device, and you can use it to fill up the tubing there with the calcium hypochlorite. As you can tell, I'm wearing latex nitrile gloves. We carry those, so we'll be glad to ship those to you. So all you have to do is place an order with us, and we'll get that. The Flaco calcium hypochlorite comes with a container that is both there are 500 milliliter size container or 1,000 milliliter size container. The product itself is a very small pellet, granular pellet. Am I saying that right? Pellet? Yeah, it's a pellet. I'm calling. It sounds like I'm saying pellet, but it's a pellet. Could you just hear it different? Okay, I gotta apologize in advance. Okay, I'm part Mexican and part white guy, so that's why I get those words confused. Anyway, I'm going to put pour the pellets into the tubing. You see how I'm just kind of like filtering it in? And by the way, not only is it recommended to go on and have latex gloves, but go on and wear your eyewear, safety eyewear as well. And you have also the, I think that's it there, folks. They're all in place. And then what you do is go on and put the cap back on this. Go on and wear safety glasses. We also have nuisance masks for nuisance odors. Those are available through Danmar, and I will show you briefly what that looks like, so that if you decide you'd like to wear one, they look like that. Okay, so that's what the nuisance masks look like. Okay, so you just saw me fill that cap up there, right? And I put the nuisance mask and the gloves in the picture too, so you can see that. Now we're going to move our way down. Okay, you see the length of that tube? It's a good length there. And as you can see, there's a brace there that holds that tubing in place. And then if I can move closer to the pellets, calcium hypochlorite pellets that have moved to the bottom of the base there. Do you see that? Okay, perfect. And I'll move the camera a little bit closer so you can read the writing on that tube. But as you can see, the pellets have accumulated on the very bottom of that tubing. And the purpose of that is, of course, is that it becomes where your calcium hypochlorite will reside. Okay. What I'm going to do is I'm going to back this up a little bit and show you what this system looks like. Okay, you see my little label there, the Danmar company label there. It's called the Danmar DM Calcium Hypochlorite System from Danmar Antimicrobial Systems. Okay, you see our phone number there, 817-822-5767. That's our technical support, our website. And as you can see, there are some technical training, video technical training, okay, that's available. Can't see it because of the tubing, but if I move that to the side there, you might see that. Video technical training available. And then right below that it says patent pending. So yes, we did apply for a patent on this device, so it's kind of neat. We're so excited about it that we thought, okay, well, let's just protect our customers' interests by getting a patent. And of course, when we take care of our customers, we take care of ourselves as well when we take that step. So anyway, I'm going to try to back this up a little bit, give you an idea of what we're talking about here. So we have a dosamatic pump. That water-driven pump, it could be a dosamatic, it could be anybody's really. The purpose of the water-driven pump and the title of this is Understanding the DM Calcium Hypochlorite System. So what I'm doing is I'm just going to put together some information for you to consider and think about on this continuing education. I'm going to try to explain the philosophy of the system and why it's designed the way it is. Once again, if you have any further questions, feel free to ask them, because we want to be of support and service to you regarding that. But if you look closer at the mini dose pump, you'll notice that we have the side injection kit on it, or remote injection kit. It's been called several different things, remote injection, side injection, but if you follow that all the way through, that remote or side injection is going into the base of the calcium hypochlorite tablets. Is going into the base of the holder or the vessel that the calcium hypochlorite tablets are in. It's going in at the base, and from the base it gravity feeds down into this valve there, and then it's add to your water stream, and your water stream is coming in on this side. The water stream enters this side of the pipe, and let's see here if I can get this right. I apologize. Let me get all this information for you together. Okay, the water enters the pump on this side. It comes out the pump, goes through this tubing to the base of this unit. So the water, the inlet water that has just entered through the pump is going into the bottom of this base manifold. And from that base manifold, it comes across this bar and then it comes back out. Okay, and there's a check valve there and a union there that'll give you quick disconnect features. And then again, I bring to your attention that globe valve, that check valve, that's a sight glass. And then we have our injection port into the base of the calcium hypochlorite. Okay, so you might be wondering, okay, what's this design all about? And I'm gonna explain it to you here in just a second. But I just want you to know that the reason why we designed I like to use the word we a lot, and I'm always cautioned with that. You know, when I use the word we, I've had some people say, what, you got a mouse in your pocket? We. I don't understand that joke, but it's been used again at me multiple times. But I designed this system, and what I did, and the reason why I designed this system the way it is that I'm very familiar with water-driven pumps. I've been working with water-driven pumps for over 12 years now. I work with water-driven pumps in the industrial market. Aside from food safety, I work with it in sanitation. I worked in it in decontamination, cooling towers. I've used it in anywhere where water treatment was needed. I used the water-driven pumps. Matter of fact, that mini dose, a lot of people don't know this about the mini dose, and I'm recording it, so if you want to contact the original Dose-O-Matic owners and engineers when they were in Carlton, Texas, you can ask them if this design pump is as a result of a conference discussion that I gave. You can find out if it's true or not. But I got invited to a conference. At that time, they had only the A12. It wasn't a mini dose. It was just the A12. I got invited to present at a conference that was being done in Carrollton with some folks from Japan. It was really exciting. Anyway, during that conversation or that discussion where I was talking about the use of the mini dose and some of my applications, I mentioned that an ideal design for the Dose-Matic 12 would be a design that would include more cycles per a given gallon per minute. So let's say that if you had 1 gallon per minute traveling through this pump, the A12, and it was seeing, let's say, and I'm throwing some arbitrary numbers, but you'll get the point when I'm finished with the arbitrary numbers. And let's say that you have 1 gallon a minute traveling through, and the cycle of this pump, and by the way, let me explain the cycle. What happens is when the water goes through here, the water drives the piston of the pump up, and then it drives the piston of the pump down. You know, the water does that, drives the piston. And so when the pump is going up, it sucks the chemistry or the water, whatever is intended to be sucked up, it sucks it up here. And then when it goes down, it pushes it through. So when it goes up, it sucks it up. When the piston goes down, it pushes it through. What I was telling them is that if you have a given 1 gallon and it has a cycle of 7 through that given 1 gallon per minute, then at a 1 gallon per minute with a given cycle of 7, it would be great if you had a given cycle of 14. And the reason why I said it would be great to have a given cycle of 14 is because the fact that you have greater oscillations or cycles, it reduces the zebra effect. Well, somebody thought it was a good idea because they came up with a smaller housing that would require this to go up and down more frequently in order to get the same volume of metered chemistry. So what happens is by the pump going up and down 14 times rather than 7 times, there was the challenge that existed was, how do we keep the same metered amount? If I have this set at 2%, how do I keep it at 2% still going through when I have this cycling 14 times? Well, that's where their engineering came in. Okay, they had to make that happen. But my point was, just have this go up and down more frequently with the same metered amount, and you will reduce the zebra effect. Okay? And I'm not going to go into the zebra effect other than to say that when the cycle goes up, it sucks in chemical. When the cycle goes out, it pushes chemical. That causes the zebra effect. The fact that you have water moving through, but yet this isn't pumping any chemical through it. Okay? So they did that, and it was a great addition to their product line. So thank you, Dosamatic. They've since been bought out by Hydroblend or Hydro Systems, and Hydro Systems now owns that trademark and that product. It's a great product, great company. I've been using Hydro Systems for a long time too. Prior to their purchasing the Dosamatic, I thought they were a great company, great product. So anyway, that's my plug for some good companies there. As you can tell that this has a remote injection, and the remote injection is going into the calcium hypochlorite. Now, what we're doing here, and what I like about my design here, is that I'm using a micro component of the total water stream as a dissolving, or I wouldn't even use the word diluting. This is definitely not diluting anything. But what it is doing is it's dissolving layers of the sodium chloride. The calcium hypochlorite. Scratch that. Calcium hypochlorite. So what's happening is that this is diluting. I used the word I didn't want to use. It is dissolving the pellet. I said that right. It's dissolving the pellet is what it's doing. So this micro amount of wetting agent, which it could be water, it could be acid, it could be an alkaline, it could be an acid, a base, it could be anything you want it to be. Okay? And that's what the patent says, is that it could be anything you want it to be. In this case, it's water. Okay? So this water is being injected here, it's being sucked into this pump, and it is being injected, and that small amount of water is cascading or running on top of those calcium pellets, and it is dissolving that in a very high concentrated form. And then that high concentrated form is going to go into this tubing here by gravity feed. And I'm gonna go on and take the camera, and I'm going to move into that area there for you so that you can take a look at that. Don't want you to miss out on any of this. This is understanding the Danmar calcium hypochlorite system. So what happens now is you have this little vessel here. You got small little micro amounts of water that are cascading into these pellets. The pellets are getting wet. They're becoming dissolved. And then that dissolved highly concentration of calcium hypochlorite is moving into the bottom of this tubing here. And the tubing we have a check valve here, and that check valve is allowing small metered amounts of this highly concentrated sodium chloride to mix, not sodium chloride, calcium hypochlorite, to mix with the water that's coming in on the bottom. I'm going to show you that now. Oops, a little bit of noise in the background. Sorry about that. It's my lighting system just kind of wanting to play havoc on me. There we go. So now what I want to do is I want to bring it down. There's the check valve I was talking about. You see the check valve? You see that gate valve, globe. It's not a globe valve. It's like a gate. It's a gate valve, but a very small gate valve that can be used to throttle volume through there. And so what happens is that there will allow that chemistry to move on into the stream of water. Okay. So remember, from the dosematic pump, the system remember when the system of I'm making some camera adjustments because I'm noticing that my camera's a little top heavy now because I've changed the pitch of my camera. So just bear with me. I'm going to pause this and make some corrections. Okay, I'm back. Sorry about that. So anyway, we have this check valve allowing the solution to go past the check valve, through the globe valve, into your body of water, your majority of your stream. Remember that this water line is coming out of the mini domes, and it's wrapping around and making its way to this manifold, and the manifold is going in this direction. The water stream is going to always be going this direction. It's going to be coming out. Now here's the neat thing about that. That water stream that's passing through there, that water stream is seeing a continuous stream of the highly concentrated calcium hypochlorite. And it's adding to it, and then what you're doing is you're titrating it with the Danmar test kit for calcium hypochlorite, and you're making sure that it is the concentration you're looking for. If you're spraying carcasses, then or carcass all the way down to the size of a quarter, and I don't mean a quarter like you have in your pocket, I'm talking about a quarter carcass. You know what, I gotta come clean here. I like to tell jokes sometimes, and so you're gonna hear a joke from here every once in a while. You know, that's gonna make me laugh. I don't know if it's gonna make you laugh, but anyway, so you got this half a carcass, you know, coming through, and you're spraying it, and so basically what you're doing is you're titrating it to make sure that you're at not to exceed 50 parts per million calcium hypochlorite onto that carcass. Now, if you're looking at primals, you know, where you've got meat cuts that are primals, then you're approved up to 20 parts per million, not to exceed 20 parts per million. So Danmar will provide you supporting documentation that will range between anywhere from 0 all the way to 50 parts per million, since we're not supposed to exceed it for carcasses, and then all the way from 0 to 20 parts per million for primals, if we're not supposed to exceed 20 parts per million. Available free chlorine is the key word that they like to use, available free chlorine. And so what does available means? It means it's between here and there when it comes to the availability of free chlorine. So somewhere between here and there, free chlorine dioxide free chlorine will be measured. Free chlorine, available chlorine will be measured with the test kit. I talked about the fact that this OLAS, the Danmar Calcium Hypochlorite System is feeding water, okay? And some of y'all are wondering, why does he throw in the word sodium chloride and these other words that are not associated with this chemistry? It's because I am a vendor that sells multiple chemistries, and this is part of a multi-hurdle design where we're offering this chemistry along with other chemistries that we have. So I may say sodium chloride, I may say acetic acid, I might say sodium chloride, hypochlorite, I might say, I could say anything because I have so many different chemistries that are available, validated, and available to you in a multi-hurdle design. So please bear with me. Nice to use that. Okay, I'm going to bring my camera around to the middle of this base, and I'm going to go on and focus down into this area here. Okay, you've got the middle of the manifold there, And then I'm going to move down into the closer into the middle portion of that manifold there. And notice there's a ball valve there, right? And I've got it semi-open. And you see that tubing there, and that tubing's wrapping around there, and it gets going up to the very top there. Bam! See that? It's going into the bottom. What we're doing there is we're adding water through that built-in capability of the system itself. So we're able to draw water from the manifold into the mini dose, and that water becomes the micro wetting agent that is used on the tablets. And you know, I'm gonna focus in on the pump here, and I'm gonna show you something really interesting. If I can get this camera to focus very closely now, I might actually move that. Oh yeah, I am definitely. I'm gonna be back with you a whole second. Okie dokie. So this pump here is a 2.5% pump. Okay, this is a mini dose 2.5% pump that I am using on the DM Calcium Hypochlorite System. Can you see that I'm actually using the smallest setting on that pump? You see that little, I guess that, to me it looks like red. I don't know what it looks like to you. It could be white. Yeah, maybe it's white. Anyway, that's where it's at. It's at the lowest setting. So that means that of the flow rate that this pump is being, this system is being tested at, I'm using a 0.5 setting on a 2.5% pump for this application. That 0.5 setting, it means a lot of things. Okay, first of all, what it means is that of the water flow rate that travels through there, let's say it's 12 gallons per minute, only 0.5% of that 12 gallons per minute, for you mathematicians that can do that math in your head, that's what it's doing, is it's only metering 0.5 of that percent of full range. So if you're 12 gallons per minute, 0.5 of 12 gallons per minute is being fed by the side injection or remote injection kit onto the calcium hypochlorite tablets, and then that solution at a rate of whatever that number is over a given minute is going to cascade over the calcium tablets or pellets, granules, into the water stream. So that is very much a micro amount of the full stream as defined by us, because what we define micro is if you have a 0.25% pump all the way to a 20% pump, we consider that a micro amount where we're concerned. So just wanted to let you know regarding the pump settings. This system is being used for testing purposes at a flow rate of 3 gallons per minute, maintaining a 50 parts per million. We're testing that right now just to get an idea of the performance curve on it, and it's doing quite well to maintain that parts per million. Now this is the nice part, is the explaining how we're able to do that. So I will be right back. Okay, we're back. Do you see where those tablets are in the clear containment vessel? On that clear containment vessel, you can feel this line here. You see my little finger there? You see that line right there? That line says, what, 100 parts per million, and then below it says 50 parts per million, and then you see it 200 parts per million. You can fill that vessel with tablets all the way to the very top. Okay? So what I'm saying is the filling of the vessel with tablets does not control your parts per million. That doesn't have anything to do with controlling your parts per million, how many tablets you put into this, okay? The reason why we have a vessel that long is so that you can fill it up and let your system run, and then whenever you need to add more tablets, you can add more or pellets or tablets or granule. You can add it as needed. But the reason why those lines are there is because when we're feeding the micro wetting agent, and in this case it's water, when we feed the micro wetting agent right in here to those little tubing there, when we feed it into the chamber there, it hits that lower base right here. It's trickling in here at a very small amount. I'll let you guys figure out the math. 12 gallons per minute. I have it set at 0.5%. And that 0.5%, we're talking ounces here, over a given minute, is gonna cascade into this, and it's gonna start washing over the calcium tablets, okay, and calcium hypochlorite pellets, and then it's going to go on and trickle down into this stream here, right in here. See that? Comes in here, and then it's going to go in through that check valve, through that globe valve, into the stream, okay? Now, let's go back over here to the top. This line here is only intended, I'm going to bring my camera in closer. I want you to imagine this. On a different video, you'll actually see this happening. But what it's intended, you see that 50? It's intended to keep your water below that. So as long as your water is below that 50 there, it will treat the water with 50 parts per million calcium hypochlorite. So that is just the water line. So that means that your water line has to be just below that level there. Okay? So, is this exact? In my opinion, it's exact in so much to say that you're going to take a measurement, and that measurement is going to give you a parts per million, and you will maintain a range within that parts per million. But there are so many variables in every system. And I'm not just talking about this one in particular, but I'm talking about every system. There's variables. Just think of it this way. If you had an acid and you were feeding it at a rate of 2.5%, then you would have a greater volume, and all you had to do was be somewhere in the 2.5% to get your performance outcome. Well, the same thing happens here with this chemistry. All we have to do is be somewhere within a range of 50 parts per million, and we're going to have microbial outcome, and that will be documented by a study. So let's say, for example, if you have a study that its base amount is 10 parts per million, and then you have a study that its base amount is 30 parts per million, both of those two studies are going to be helping and supporting if you're running a chemistry that's above 30 parts per million. So that means that when you're using a chemistry above, you've titrated it, and you know you're above 30 parts per million based on your titration, whether it be a paper titration or a drop-by-drop titration, and you know that you are above 30, then you're going to have a micro reduction greater than either the 10 part per million or the 30 part per million. It's greater, so it stands to reason that your microbial reduction is going to be greater. So that's the reason why that number is there, that 50 parts per million, and that level there is intended to measure what your water level is. So that line there, as long as your water level inside this vessel is below that, you're going to get a steady range of chemistry below 50 parts per million, but measurable within that range, okay? So you'll have to work with it. When I was testing this at 3 gallons per minute at that setting that I just showed you, 0.5%, I was using my paper strips and I was getting the same color comparator reading each and every time. When I went to the drop-by-drop titration, and we sell both test kits, they were within range. I mean, we're talking about an error rate. I'm gonna bring up one other thing for you so that you feel comfortable with what I'm talking about. If you have a test kit and your test kit is being used, you must understand that your test kit comes with a manufacturer's percent error range over range, okay? And the test kits that we use from the manufacturer we buy it from has a error range of 10% over full scale. So if you're looking at 50 parts per million, you have a percent of range of 10% that you could have an error of. The higher that part per million that you're measuring, the range of error is going to still be 10%, but it has a greater number range that you're going to be different of. Now, that's accumulatory. The error range is accumulatory. And what do I mean by that? Well, you have the test kit that has a represented error range that you're working within, and then your pump has a error range, and so the accumulative effect of the error range of the pump and the error range of your test kit could make it seem that you have a significant error. Well, you don't have a significant error, I assure you, within that range, but you do have variables that you have to control and you have to keep in mind. So at Danmar, we understand that, and a lot of our supporting documentation is done at a point where you have a great deal of latitude with that supporting documentation for your particular plant and so forth. So anyway, I'm wrapping up this portion of understanding the DM Calcium Hypochlorite System. And next time we have a video presentation, it will be the operations and the performance of the Danmar Calcium Hypochlorite System. But this was just to serve as an understanding of it, and then we will go into a little more detail later on. Thank you very much for your business. Thank you very much for your time. And feel free to give me a call or email me at danmarco1 at msn.com if you have any questions. Thank you for your business.